Lesson 8-2, using the distributive property. So we are going to use the distributive property, which you saw in Chapter 7, Lesson 7, and that was when we were distributing a number to a number. So we were taking it inside. What we're going to be doing over this unit is actually going backwards. So you're going to kind of have the answer, and you're going to be pulling numbers to be out front of those parentheses. So factoring a polynomial involves finding the completely factored form, meaning it cannot be factored any smaller. When using the distributive property to factor polynomials, you have 4 or more terms, and that's called factoring by grouping. A polynomial can be factored by grouping only if all the following conditions exist. There are 4 or more terms. Terms have common factors that can be grouped together. And there are 2 common factors that are identical or additive inverses of each other. So let's take a look at this example. So here we have 15w minus 3c. So you first want to look at the coefficients. And you want to determine, is there anything that I can pull out of both of those that would make this a little bit simpler? So we could pull a 3 out front, and if we did that, then we would be left with 5w minus c. And so then that would be our simplified answer of using the distributive property to factor each polynomial. Pause the video to try a few examples. So for the first example, we have 7u squared t squared plus 21u t squared minus ut. So just by looking at this, you can see that you have multiple ut throughout the entire polynomial. So we're going to pull the ut out front. So now you have to determine, what does that leave us? Well, that leaves us a 7ut plus 21 with just one t, and then minus 1. So now if you wanted to check it, you could distribute this to everything within the inside and make sure that you got your final answer. We also have negative 4a squared b minus 8ab squared plus 2ab. So for this one, you can take out a 2ab, and that's going to leave behind a 2a, negative 2a, because you have a negative 4, a negative 4b in the parentheses. Now, you could do the plus 1 at the end just so that you know that this is also adding the 2ab, so I forgot that in there. So your final answer would be 2ab times negative 2a minus 4b plus 1. When we're doing factoring with grouping, what you want to do is you want to group terms with common factors. So looking at this example here, our common factors are 4QR and our 8R, because they both have an R in them. And then we would also pair together the 3Q and the 6. They don't really share anything other than the coefficient, so the number of each of these could be paired together. So now you want to look at, well, what can I pull out of the 4QR plus 8R? We could pull out the 4 and the R, which would leave us with Q plus 2, because remember, you always multiply. Sorry, that should have been a plus sign there in the middle. And then you have this plus, and over here you can pull out the 3, so you would have Q plus 2. So now you can notice that q plus 2 is common in both groups. So that actually becomes your greatest common factor. So what you would then do is you would have your 4r plus 3 times q plus 2, and that would be your answer for factoring the original equation. So if you can see, this is kind of doing the FOIL method backwards, because if you had the answer here, you would do the FOIL method to get the original polynomial you had. So we can also do grouping with additive inverses. You first want to group together the terms that have common factors. So those common factors would be 2mk and 12m, because they both have an m, and then 42 and 7k, because 42 and 7 have something in common. So we start factoring. We pull out 2m, so that's going to be multiplied by k minus 6, and then that's going to be plus, and now for this one you could factor out the 7, which would leave you with 6 minus k. Now by looking at this, you can see that k minus 6 and 6 minus k are almost the same, but they're actually opposite of each other. So what we can do is we can actually multiply one of these by their additive inverse. So we could do 2m and then k minus 6 plus 7 times negative 1 times 6 minus k. So what that would actually leave us would be the 2m k minus 6 minus 7 times k minus 6. So when you distributed that negative there, it kind of did the associative property and you kind of flipped some things around. So now we just have the distributive property and we get 2m minus 7 times k minus 6. So I think the most confusing part here is probably going to be these two steps. Just remember that if you're multiplying the 7 by negative 1, you also need to multiply the inside the parentheses by that negative 1, which kind of will flip things around a little bit, making it a positive 6, or a negative 6 and a positive k. Well, we always want to write it where the variable is first. So that's where it got the k minus 6. Another way to kind of look at this is to also put brackets around here so that you see that it's actually negative 1 distributed in first, and then you multiply by the positive 7, and so positive 7 times negative 1 is negative 7. Pause the video to try a few examples on your own. So for the first example, we have rn plus 5n minus r minus 5. So you want to group them together, and then you kind of want to go from there to separate. So for the first one, I'm going to pull the n out front, which is going to leave me r plus 5. For the second one, I'm going to pull a negative 1 out front, which is going to leave me an r plus 5. So now we combine those and we get n minus 1 times r plus 5. And if you use the FOIL method to test that, you will get the correct answer that you originally started with. And for the next example, I might run out of room on this one, but we are going to combine our 3p and our negative p squared, and then our negative 18p plus 27. So the first thing you want to do is you want to pull the p out front, so you're going to have 3 minus sorry, this should be a 2p squared. Sorry about that. Would get you 2p plus 9 times negative 2p plus 3. So if you look at these are actually the same. They're just using the additive inverse to rewrite them. So if we rewrote this up here to make it look the same, it would actually be p times negative 2p plus 3 plus 9 times negative 2p plus 3. So that means that we can just do p plus 9 times negative 2p plus 3. Again, sorry about that mistake of the negative 2 adding in there. And the last thing we're going to look at is the zero product property. And what that means is if the product of two factors is 0, then at least one of the factors must be 0. So let's take a look at this example to see what that means. So here we have 2d plus 6 times 3d minus 15 equals 0. So you want to separate this into two equations and solve for d each time. So the first one is just 2d plus 6 equals 0. So you would subtract 6 from both sides and get 2d equals negative 6. And then you get d equals negative 3. And for this equation, you have 3d minus 15 equals 0. You add 15 to both sides. You have 3d equals 15, and then you divide by 3 to get d equals 5. So your solution for this, and you would actually call these the root. So the roots for this equation are negative 3 and 5. Let's do one more example that looks a little bit different. So we have c squared equals 3c. So what you first need to do here is you need to subtract 3c from each side so that you can get 0 on one side of the equation. So let's subtract 3c from here. And so we're going to have c squared minus 3c equals 0. So now to solve for this, you want to solve as if this were a factored equation. So you have to factor it. So you put the c out front. So now it's c minus 3 equals 0. So then you can start solving for c. So for the first one, it would just be c equals 0. The next one would be c minus 3 equals 0. So you add 3 to both sides. So the root of this equation would be 0 and 3. So if the equation is not already in the form where it equals 0, you have to set it to equal 0, and then you need to factor those polynomials before you can determine the two roots of the solution. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of watching this video.